Alright, this is chapter 10, number 12. We have a wheel that has a diameter, turntable, yeah, it's a 64 centimeter diameter wheel. So has a diameter of 64 centimeters. Change that to meters and you get 0.64 meters. It's got a radius of 32. I just took 0.64 and divided it by 2 to the radius. It tells us that the initial angular velocity is 130 rotations per minute. I changed that per second using 2 pi over 60 seconds. Okay. The final angular velocity is 280 rotations per minute. I changed that radians per second using the factor here, 2 pi over 60 seconds. And it says it does that in time of 4 seconds. The first question is, what's the angular acceleration of the wheel? The angular acceleration, if we look in our toolbox, is the change angular velocity over the change in time. That's the average acceleration. So let's find the angular acceleration. So initial over time. If you plug that in, you get 3.9. Ooh. Let's try that again. 3.9269 90808. That's radians per second. Okay. Now, significant figures ask for 2 digits, so let's do 3.9 radians per second squared. That is the average angular acceleration. The next part asks for the components. The components of the linear acceleration. So the components are tangential acceleration and radial acceleration, or centripetal acceleration. Let's look at the tangential acceleration. The formula to find that is the rate of the angular acceleration. So that's 0.32 meters, 3.9 calculator. I actually did the whole number, so when I did, instead of using 3.9, I did the 3.926990808. Okay. Tangential acceleration. 1.256637058 meters per second squared. That's right, it's meters per second squared because we multiplied something meters, the radius. So meters times radians. Radians is an invisible unit, so you could write meters times radians over second squared if you want, but meters per second squared. Putting it Putting it in the significant figures is 1.3 meters per second squared. Alright, last but not least, the rate of acceleration. The formula for angular velocity squared times radius. Now here's an interesting question. Which angular velocity do we use? There's a final and an initial. Well, they say it's when the time passed is at 2 seconds. So the way to figure this out is just like velocity, linear velocity is linear acceleration times time. What's also true is angular velocity is determined by the angular acceleration times time. So really, the angular velocity we're using is 3.9 radians per second squared times 2 seconds. So we're using 7.8539816 meters per second. This is not meters. This is radians. It's angular, and there was nothing used to make it meters. Okay. So, plugging that in for AR equals this squared, 1.853981616 squared, times the radius, and the radius upstairs was 0.32 meters. So we get 19.73920.871 meters per second squared. Okay, and this uses meters because we multiplied it by the radius. So significant figures, it's 20 period meters per second. Let's try that again. .meters per second squared. Okay, and you're done.